there. Let's talk about kind of a continuation of conditionals. We're going to talk about biconditionals and how they create definitions for us. We're going to combine this with some deductive reasoning. We've done inductive. Now we're going to do deductive. We're going to tie this all together. It's kind of a long lesson, so I'm going to fly. If you need me to slow down, maybe you have to pause, stop it, and rewind, listen again if you have to. But I'm going to try to abbreviate a lot and keep it going. Here we go, a biconditional. Now remember that a conditional is like an if-then statement. That's what a conditional is. If it's a biconditional, instead of writing it an if-then, it's written with an if and only if, and they tuck that in the middle. And what that means is that it is true, but also if you switch it around and make the converse, that's also true. It works both ways. So like in this example, an angle measures 90 degrees. If and only if it's a right angle. I could have written this, if an angle measures 90, then it's a right angle. Yes. If it's a right angle, then it measures 90. Yes. It works both ways. So we would call that a biconditional, and we'd, instead of writing it both ways, we just stick an if and only if in there, and we know that it works both ways. So let's practice them. It says, what's the converse of the following true conditional? And if that converse is true, we're going to rewrite it as a biconditional. If two angles have equal measure, then the angles are congruent. All right, I'm going to switch it around. If two angles, remember I'm going to try to abbreviate a bunch here. If two angles are congruent, then they're equal. Is that true? You got two angles that are congruent. Remember, that means you can pick one up, it lands, you can lay it right on top of the other, they match up exactly. Then their measures would be equal? Yes, I think that's true. So then I come back, and what I can say then is, instead of doing if then, I'm going to go back to the original, and I'm going to say two angles have equal measure. Sorry, it's so messy. If and only if angles are congruent. Meaning I could have written that either way and it works. There's no counterexample to that. All right, let's practice this a little bit. What are the two conditional statements that form this biconditional? So they've already given us the biconditional. Now we're breaking it down to the if-thens. Going the other way here. So I'm going to start off, and I'm going to say the ray is an angle bisector. That's the P. So I'm going to think of this as the P. Divides an angle into two congruent angles. That's the Q. So I'm going to start off. Don't do the if and only if. I'm going to get rid of the if and only if. And it's going to be if a ray is angle bisector. Sorry, terrible grammar today. Then it divides an angle to two congruent angles. Okay. If a ray is an angle bisector, then it divides an angle into two congruent angles. I agree with that. That's true. Now what we do is we switch that around. Since it was a biconditional, it's supposed to work both ways, so let's flip it. If an angle, we always like to put the subject first. You know, what are you talking about? So I'm talking about an angle. So if an angle divides, I'm sorry, not if an angle, if a ray divides an angle into two congruent angles, then it is an angle bisector. If an ray divides an angle into two congruent angles, okay, I'm envisioning that, it cuts it into two congruent angles, then that would have to be an angle bisector. Yes, it works both ways. All right, so that's all a biconditional is doing, is switching or showing that it works both directions. It's true both ways. All right, I'm just going to talk through this one. We're not going to necessarily go through it the whole way. And this is a got it, but like I said, this is a long lesson. We're going to shortcut here. Is this definition of a straight angle reversible? If yes, write it as a biconditional. All right. A straight angle is an angle that measures 180. The P is the straight angle, measures 180 is the Q. So if it's a straight angle, then it measures 180. True, that's what a straight angle does, yes. Let's flip it around. Okay, so I'm going to say that works. If I were to write it, now it's not really about true or false today, it's really about can you write it into an if-then statement. So you're just putting the if at the beginning, the then, and before the second part. Let's flip it around. If an angle measures 180, then it's a straight angle. If it measures 180, yeah, that's what it does. Yep, that's right. So then could we write this as a biconditional? Notice this notation right here, that a biconditional, instead of having it like an if-then with an arrow, it's like a two-sided arrow. It goes both ways. That's how I know it's a biconditional. I'm going to go ahead and write this. An angle is straight. Oops. If and only if it measures 180. That's kind of how you have to make it kind of sound right. Grammatically, it's hard to write that. That's kind of the hardest part sometimes. Now, this is one more of them. Is this definition of a quadrilateral reversible? If yes, we'd write it as a biconditional. So one more time, just practicing this, and the more you do it, the easier it becomes. So it says, can we write it the first way? Remember that the quadrilateral is going to be the P, polygon with 4 sides is the Q. If it's a quadrilateral, then it's a polygon with 4 sides. Yes, that's what a quadrilateral is. That's what quad means. It has 4 sides. Let's switch it around. If the polygon has 4 sides, then it's a quadrilateral. Yep, that's true. So can you do this? If it works both ways, can you write the biconditional then? You write it both directions. All right, I'm going to move on. A figure, you sometimes have to put an extra subject in there. A figure, like we did on the last one, I kind of did that. A figure is a quadrilateral if and only if it is a polygon with 4 sides. Now, the whole point of doing this is that if we have a definition, and these ones that have been given you, they are definitions, that's why they've been working so great. A good definition can actually be written as a biconditional. If it's not a very good definition, you should be able to find a counterexample. So I thought this was kind of a neat one. It's multiple choice. There's only one of these that's really a good definition. And so let's see which one that would be. On A, a fish is an animal that swims. All right, you have to think of that as an if-then statement. If fish, then swims. Let's just cut to the chase. If it's a fish, then it swims. But it should also work the other way. If it swims, then it's a fish. What do you think on that? Could you come up with a counterexample? There would definitely be a whale, maybe. It swims. It's not a fish. So there would be an eel. I don't know. You could come up with all kinds of animals that aren't really fish that still swim. How about a person? Okay. I'm going to say A would not be a good definition because it doesn't work both directions. All right, let's go to B. If it's a rectangle, it has 4 corners. Yes. How about the other way? If it has 4 corners, then it's a rectangle. Nope, it might be a square. And in fact, it doesn't even say that they have to be like right angles, so it might be a trapezoid or a rhombus or some other weird shape too. So I don't think that one would work either. Giraffes are animals with very long necks. That's true, yes. Switch it around. If it's an animal with a long neck, then it's a giraffe. Well, what are some other animals with long necks, right? Okay, so it could be like a flamingo. You know, there's lots of animals I could come up with that would have a long neck. They aren't giraffes. Not going to work. Boy, I hope this last one does. If it's a penny, it's worth 1 cent. Yep. If the coin is worth 1 cent, then it's a penny. There we go. That's the one that finally works both ways. That's how we know that these other ones, like when you're defining things, you have to be careful when you make a definition. It has to make sense in all scenarios. Okay, we're going to move on to 2.4 then. This is on deductive reasoning. The inductive reasoning that we previously did meant that you were making some sort of conjecture based on a pattern. Okay, deductive is a little bit more concrete. There has to be like tried and true, this is really works by rules or definitions or theorems or postulates or some kind of rules that we've had. It's not just based on a pattern. Now, okay, sometimes we call that logical reasoning, and so that's where this next thing that we're going to do, I think it's kind of fun. Have you ever done those logic puzzles? We're going to try one, and then you're going to have one for your homework. All right, so here's how these work. You have all this information given to you, and you're supposed to kind of break it down and get all the details. So on this one, the local aerophobe support group has several members who each need to take a flight. Match each aerophobe to their flight date and destination and determine what lucky charm each intends to bring with them. All right. So here's what I've got. We kind of make up a grid, and we'll always give you the grid so you don't have to create this. But they give you some clues, and you're supposed to figure out who goes with what. All right. So I'm going to start off and go through each one with us, and we're going to X out things that aren't going to happen and then see if we can figure out what truly does. The passenger leaving in February is either Jamie or the flyer with the coin. Okay, that gives us a couple pieces of information actually. Passenger leaving in February is either Jamie, okay, so Jamie might be February, or the flyer with the coin. But what that really is telling me is Jamie and the flyer with the coin are two different people. So Jamie and flyer with the coin, I'd put an X through that. That's not going to be Jamie. Now, I'm going to have to come back to the February thing because I don't know that they've given me enough. Well, I could say, well, I don't know. I can't even do that because February could be Jamie, so this might be it, but I don't know who the flyer with the coin is yet, so I don't know which the other option is. So I'm going to come back to that. I bet they're going to give me some more information that will help me. It says, Jamie will bring a rabbit's foot. Well, okay. That just told me then, flat up, Jamie's rabbit's foot. So what I do is I shade that box in. And that's going to be the answer that I need. Jamie, rabbit's foot. They go together. Which also means that Jamie is none of these, and rabbit's foot is none of these. All right. Let's keep going. Troy will leave sometime after the passenger with the lucky hat. Okay, this tells us a couple things. Now we're using this deductive reasoning, thinking through what this means. If he's leaving after the passenger with the lucky hat, that means he's not the guy with the hat. So I'm going to cross off Troy and lucky hat. That's not him. That also means, if you go back to the other part, it says Troy will leave after the passenger with the lucky hat, which means he's not the first to go. Somebody else is going first. So I'm going to X out Troy in January. He wasn't the first one to go. Troy will leave 2 months before Peggy. Ooh, okay. So now this is really starting to break down a little bit more. If he's leaving 2 months before Peggy, he would have to be leaving right here, because otherwise we don't have 2 months to work with. So Troy is going to leave in February, which also means Peggy then is going to have to be April. So let's fill those in. Now as soon as you color in a box, you can always fill in the X's both directions from it because you've determined that entirely. So I'm going to fill in my X's each direction. And that starts to limit some things for sure here. But I'm also all done with my clues. When you do that, now you start over. Because they gave me some more information about, now I know about February, so I bet you this clue at number 1 is going to help me. The passenger leaving in February, who we now know is Troy, is either Jamie or the flyer with the coin. Well, Troy is not Jamie, so Troy is the flyer with the coin. So now I've got that. And I can start then, I can X out both directions from the shaded in spot. Okay, keep going here. Okay, I guess before I even do that, once you start getting a match, then what they really want us to do is kind of list these out. So I've got Iris, I've got Jamie, I've got Peggy, and I've got Troy. Okay, and along with that, I know that Troy has the coin. Well, Troy is going to be February, and he has the coin. We kind of want to like have a final answer of how this all matches up after the grid is done. Troy is February, takes the lucky coin. But now I know all 3 of those match. So right here, when I have this filled in and I have this filled in, I also can go this way. February matches with the guy with the coin. So I know this one is filled in. So I can do that. I'll fill that in and say, well, February is not going to go with any other lucky charm, and the coin is not going with any other month. Okay, I don't think that I have, well, let's go ahead and fill in. I guess I know Peggy is April. And I know Jamie is Rabbit's Foot. All right, now I could probably turn you loose and you could finish this. I'm going to go ahead and finish it with you. Like I said, you're going to have 1 for your homework. Okay, I redid question 1, or clue 1. I'm going to go ahead and redo question 2. Jamie will bring the rabbit's foot. Oh, did I write that wrong? Did you catch that? I wrote that on Iris, and that was supposed to be Jamie. Sorry. Don't mean to confuse you. Okay, next one. Troy will leave sometime after the passenger with the lucky hat. Well, that also means lucky hat must be first then, right? Since we now know Troy was February, lucky hat must be January. So if lucky hat is January, let's find where those match up. That's right here. Lucky hat, January. And I really don't know yet. Well, I do know now. I can tell. Okay, boom, 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 boom. Lucky hat and January. The problem is January is either Iris or Jamie, and Jamie's already connected to the rabbit's foot. So that must mean it's going to be Iris with the lucky hat. And so we can fill that in. This is the hat. And then that means January for Iris. All right, and then it starts to just fall out. If you start putting your X's in here, that leaves you only this option. Jamie's going to have to be March. And then when you start doing it down here, I fill those in, but sometimes I get anxious and don't put in my X's, but here it is. It's all figured out there. All right, the talisman goes with Peggy in April. And once you get to this point where you can fill in the chart, you don't necessarily have to continue filling in the grid if you want, because ultimately your goal is to figure this out right here. Okay, these are kind of fun. I enjoy them. I'd do another one with you, but you probably want to move on. Okay, the idea of this deductive reasoning, like I said, it has to be based on some sort of a rule or definition. And really what it is it's a law. We have 2 laws that we pay attention to. One of them is the law of detachment. The other one's the law of syllogism. You really got to just pay attention to the P's and Q's on it, and it's really easy. Don't get lazy about doing the P's and Q's. For the law of detachment, and this is you trying to make some sort of conjecture. All right. If you are given a true conditional statement, so you have some sort of if-then statement, and you know that it's true, and you also are given that the hypothesis actually did happen, and sometimes it's like more specific. It'll say, oh, Bobby is blah, 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 and they actually put a name to it or something. All right, so you know this if-then statement, and you know the first part is given, then you can go ahead and conclude the then part of it. All right, let's do this a couple times. Here's an example. It says, if the horse has a single horn coming out of its head, then it's actually a unicorn. All right, so I'm going to say, oh, the horse has a single horn, that's the P. Then it's a unicorn, that's the Q. Now for law of detachment to work, this is how, just on that previous slide, you have to be given if P then Q. You have to be given P. Then you get to say Q. It has to be just like that. You can't like do the if P then Q and then have a Q here. So let's see. Given if P then Q. Got it. Now, the horse has a single horn coming out of its head. That's the P again. That's what I want it to be. And because it lines up just perfectly, I get to say the Q part. I get to say, oh, it's actually a unicorn. Let's practice a few times. And again, I'm going to write this up here so you remember you're just paying really close attention to the P's and Q's. They're going to give you if P then Q. They're going to come back and give you P. You're going to say Q. But if this does not happen just like that, then you're not going to be able to make a conclusion. All right. If a student gets an A on a final exam, then the student will pass the course. Okay, gets an A on the final is P. Pass the course is Q. So I've got the first part. They gave me the if then, if P then Q. Did they come back and say P? Felicia got an A on her history final exam. Oh, that is, right? A on the final exam. They came back and gave me P, but we're talking about Felicia. So then I can come back and make a conclusion that Felicia will pass the course. Now this deductive reasoning that we're doing, I always think of it kind of like what lawyers actually use is, you have to kind of follow step-by-step process and follow this through, and just if you switch it around sort of and twist what really happened, if you twist the if-then the other way, it doesn't always work out, but it can be sneaky. So we really have to be very straightforward and in a distinct process to make sure what comes out at the end is really true. Let's try this next one. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. That sounds similar to one we did earlier. Ray divides an angle into two congruent angles. Okay, so you got this ray dividing into angles. Then we're going to say that's an angle bisector. That's the Q. That's the if P then Q. They got to come back and they got to follow up with P. P is a ray divides an angle into two congruent angles. So right here it says ray RS divides this angle. Oh, okay. I'm going to sketch a picture, but that seems like that's going to be right. RS divides angle ARB. So this is ARB, and RS is a ray that divides so that ARS and SRB are congruent. All right, that's dead on what I want. That's what P is. A ray divides an angle into two congruent angles. Then I get to come back and say the ray is an angle bisector. But I'm going to be specific here, and I'm going to say angle R, or I'm sorry, not angle. Ray RS is an angle bisector. Last one, why don't you try this one? All right, let's see how you did. It's got to follow the same pattern. If two angles are adjacent, then they share a common vertex. That's P, and if P, then Q. So that's the first part. So then did they come back and give you P? Did they talk about two adjacent angles? Angle 1 and 2 share a common vertex. They didn't. They actually came back and gave you Q. All right, that don't work. You can't switch that around. Angle 1 and 2 share a common vertex. That does not, I can't come back and switch it and say, oh, then they're adjacent. It has to follow in this exact order. I can show you an example right here. Here'd be angle 1, and here's angle 2. They share this same vertex, but they are not adjacent to one another. So you can't switch that pattern. It's got to stand by that exact pattern. That's called the law of detachment. Okay, so these are your, I guess I got ahead of myself and gave you that other one. These are really supposed to be the ones you're supposed to do. So why don't you pause the video and see if these work. Can you make a conclusion? If you can't make a conclusion, just state that. Pause the video. All right, on this first one, I can see that it went if P then Q, and it came back with P. That's what it's supposed to do. So then my conclusion on that would be that Marla, being specific in my conclusion, Marla is not safe out in the open. The next one, when you put the P's and Q's on it, goes if P then Q, and it comes back with Q again. That's not what it's supposed to be, so I'd write no conclusion. Don't get sucked in. It's going to be really tempting to just follow right up with what seems like the other part should be, but it's got to be in the right order. Okay, the other law, that was law of detachment. The other law that we can use is called the law of syllogism, and it's a little bit more complex. There's a little bit more going on, but again, we're just going to follow the pattern of the P's and Q's. The way that the law of syllogism works is that if you have two true conditional statements, and the conclusion of the first is the hypothesis of the second. So you're going to see that twice. All right, so that's how the first part, that's given to you, two conditional statements. If that's the way it works, you can come back and make a conclusion and go straight from P to R. You can see right here would be my conclusion then. All right, so I'm going to write that. I'm going to put my P's and Q's, and it's got to follow just like this. So here we go. Here's my P and Q. If the horse has a single horn coming out of its head, then it's a unicorn. We talked about that, yes. So that's an if-then. If P, then Q. And then I have to follow up with a if Q, then R. So I've got to talk about the unicorn again. That's how it's got to start. If it's a unicorn, then it's imaginary. That's something new. All of a sudden, you're going to have this third thing going on now. Okay, so if P, then Q, if Q, then R, then my conclusion gets to come back and go straight from P to R. So I'm going to say, if the horse has a single horn, then it's imaginary. That makes sense? Let's practice some. I'm going to write this up here to force you to remember to do this. If P, then Q, if Q, then R, then you get to say if P, then R. If it doesn't follow that exactly, you don't get to make any conclusion. So if a figure is a square, then it's a rectangle. If a figure is a rectangle, that's actually Q, right? Then it has four sides, there's my R. Did that follow the path it was supposed to? Yep. P then Q, Q the R. Then I get to come back and say, if a figure is a square, then it has 4 sides. All right, let's try the next one. If you do gymnastics, that's P, then you are flexible, Q. If you do ballet, that's the new thing, then you are flexible. All right, what do you think? You do not get to make any conclusion here. It didn't go in the right order. It was supposed to go if P then Q. This is supposed to be Q then R. They didn't do it in the right order. Doesn't work to make a conjecture that way. So I'm going to say no conclusion. All right, these are yours to practice with. So take a moment to pause the video. Try these Law of Syllogism problems on your own. All right, check over your answers. Make sure that you agree with me. And then when you're ready, go ahead and move on. All right, I kind of feel like we've done several examples. I'm going to call it good here. If you want to call it good, you can. Actually, I'm going to quick write the answers. No, I'm not even going to do that. I'm going to say we're good. Let's move on. Your homework tonight is Math Excel, but I want you to do one of the logic puzzles right here. It kind of randomly generates a logic puzzle for you. So if you go to this website, do your logic puzzle, and do a screenshot of your success on figuring it out, and email me that screenshot. Or another thing, you could just take a picture of it. If you want to do a picture of it, save me from getting 40 emails. That'd be awesome too. All right, good luck.